So on page 2 of your parametric notes, the first thing we start talking about is collision points versus intersection points. And basically the power of these is, think about when you are flying in an airplane. If you fly in an airplane and somebody goes from, let's say, Ohio to Texas, and somebody else goes from San Francisco to Myrtle Beach, when they do that, the paths of their planes are going to cross, but hopefully their planes are not going to collide in the air. And that's why we have parametric equations, because it gives you an idea of where things are and when they are what they are. So if you want to figure out algebraically if things collide versus just their paths crossing, what we can do is have two pairs of parametric equations, x and y1 and x2 and y2. You replace them with different variables. So let me give you an example, the one down here, all right? If you have two ghosts moving in a room and their paths are modeled by these two pairs of equations, technically this t belongs to x1 and y1, and this is technically a different t, and it belongs to x2 and y2. So what we do to eliminate that confusion is we just say, you know what? Let's give the first ghost x equals 2t, and y equals 4t minus t squared. And then let's give the second ghost x equals w plus 1, y equals 4 minus w. Just give them a different letter. Now, if these ghosts are going to have paths that cross, that means their x's are equal for some value of t and w, and their y's are equal for some value of t and w. Solve that system of equations. I'm going to do that by adding them together, which cancels out the w's. So I have 6t minus t squared equals, let's say, 5. 0 equals t squared minus 6t plus 5. So, come here. So, let's see, 0 equals t minus 5, t minus 1, t equals 5 and 1. And then w, 2t equals w plus 1, so 2 times 5 equals w plus 1. When t is 5, w would have to be 9. And 2 times 1 equals w plus 1, w would equal 1. So, at t equals 5, w equals 9, that means their paths cross. Now, where do they cross? Well, if t equals 5, t belonged to the first pair. At t equals 5, x is 10, and y is 20 minus 25, negative 5. If I plug 9 into here because I made these w's, I should get the same thing, and I do, 10 and negative 5. At t equals 1, w also equals 1, which means they collide and pass through each other because they're ghosts. At, well, if t equals 1, x is 2, and y is 3. All right, now we get into the calculus of parametric equations. So, whenever you need the slope of a curve or anything that requires dy dx, since y and x are separate, we get dy dx in parametrics by simply doing dy dt and dividing it by dx dt. Makes perfect sense, right? dy dt divided by dx dt will give you dy dx. Part of the reason that works out is because if you do a keep switch flip, we have dy over dt times dt over dx, which is basically dy dx. Now, technically, you're not really allowed to do that with the notation, but it works, so just kind of accept that as a good reason for why this is the formula. Now, the second formula is a little challenging. If you have the second derivative and you want to know anything about concavity or inflection points, things like that, the second derivative, d2y over dx squared, isn't just the derivative of the first derivative. It's the derivative of dy dx with respect to t divided by dx dt. Now, I'm going to give you a reason why that works. Just accept it and move on. But basically what happens here is d2y over dx squared is d dx of dy dx. Okay? And if I want d dx of dy dx, I really want d dx of dy dt over dx dt, which I can write as d dt of dy dx over dx dt, because if I keep switch flip again, and I know it's weird, pardon the bell if you hear it behind me, d dt dy dx, keep switch flip, dt dx. This dt cancels with that dt, and I have d dx of dy dx. Honest to God though, long story short, ignore everything I just said, memorize the rule. If you want the second derivative, you take the derivative of dy dx and divide it by dx dt. So if we want to find dy dx and d2y over dx squared, the second derivative, for the two ghosts in example above, ghost number 1 and ghost number 2, so if I look at my first guy, ghost number 1 was x equals 2t, y equals, what was it, 4t minus t squared. If I want dy dx, I do dy dt, which is going to be 4 minus 2t, divided by dx dt, which is 2, and that simplifies down to 2 minus t. There's dy dx. If I want d2y over dx squared, I take the derivative of dy dx with respect to t, that's going to be negative 1, and divide it by dx dt, so divide it by the derivative of x, which is 2. And if I do ghost number 2 over here, it was t plus 1, 4 minus t. So if I want to do dy dx, I do dy dt, negative 1, divided by dx dt, 1. That's going to be negative 1. There's dy dx. And d2y over dx2 is the derivative of dy dx, 0, divided by dx dt, 1. So my second derivative equals 0. Long story short, though, for derivatives, the first derivative is just the derivative of y divided by the derivative of x. The second derivative is the derivative of dy dx divided by dx dt. All right, that ends page 2.